Every few decades, a visitor from another star drifts into our solar system. For centuries, we believed the universe was quiet, empty, predictable. But now that illusion is fading. Meet 3I Atlas, an interstellar object moving faster than anything we've ever tracked, with a trajectory so precise, it almost seems deliberate. Captured by the James Webb Space Telescope, its data exists. And yet we can't see it. Why? What is being hidden? And could this be more than just a rock passing through? Today, we dive into the mystery of 3I Atlas, and what it might mean for humanity. Something was detected. Something measured then hidden away. No public images, no released data, no press briefing, only silence. The James Webb Space Telescope locked onto it, recorded it in infrared, studied it, and then sealed the findings. When questioned why even he has no access yet, the response was simple: the data takes time to arrive. It could take them a month or two to publish a new paper. Maybe by early October, we'll finally see it, the first official glimpse of what this object really is. But the object isn't coming. It's already here. So we have to ask, if there's nothing unusual, why is the data locked away? And why does this keep repeating? This isn't the first time. James Webb has aimed at strange objects before, captured them, and then, nothing. Hidden behind technicalities. A silence that feels like more than silence. It's not random. It's structured, engineered into the system itself. Because despite what most people think, the James Webb Space Telescope isn't run solely by NASA. Control lies with a private research consortium, the Space Telescope Science Institute. And the ones who decide what gets seen aren't elected, aren't accountable, and aren't transparent. They're scientists, yes, but also gatekeepers. Here's how it works: each year, a select few institutions are granted precious observing time. They submit long, technical proposals, written in coded scientific language. If approved, they receive exclusive access to the data. That's right, a public telescope, yet private results. For months, sometimes up to a year, only that original team can see what Webb observed. They can publish, they can delay, or they can stay silent. And with 3I Atlas, that's exactly what happened. One team, led by Martin Cordiner, submitted a proposal and it was approved. They aimed the telescope, scanned the object in infrared, and captured a complete spectral cube, more than 40 gigabytes of raw data. And then, they locked it away. 3 months under embargo, the minimum allowed. They could have lifted it with a single click. They didn't. Why? Why would a team of scientists, studying one of the only interstellar objects humanity has ever seen, choose silence over disclosure? They'll say it's protocol. That they need time to analyze. That they deserve first rights to publish. But this isn't some distant galaxy. It isn't just another cold star. This is a visitor passing through our solar system only once. When it leaves, it won't return. So is this really just about academic credit? Or is there something in the data they're not ready to reveal? Because here's the part that doesn't add up: another proposal, from a separate team led by Matthew Pellico, used directors' time to study the very same object. Their data? Released instantly. 2 observations. Same telescope. Same object. One locked, one public. Why the difference? What did the first team see that the second didn't? And it isn't just the data that's strange, it's the path. Most interstellar objects drift into our system like cosmic tumbleweeds, thrown by gravitational chaos, racing through at sharp, unpredictable angles. They come fast. They leave faster. But 3I Atlas is different. Its orbit is retrograde, moving against the flow of our planets. Already rare. But then, it gets stranger. It rides almost along the ecliptic, just 5 degrees off the very plane where Earth, Mars, Jupiter, and the major planets circle the Sun. That kind of alignment is anything but common. Most interstellar debris crashes in from above or below, wild, chaotic, untamed. But 3I Atlas enters differently. Like a probe. Flat. Stable. Calculated. And then comes the path it takes: Mars, then Venus, then Jupiter. 3 planetary encounters, in that precise sequence. As if it's sampling the inner solar system. Mars, the barren desert. Venus, the inferno. Jupiter, the gas giant. A tour of extremes. What makes it stranger? The sequence runs backwards against the natural pull of gravity, not falling inward, not being dragged along. It's as if 3I Atlas chose its route. Avi Loeb, Harvard astrophysicist and cosmic provocateur, didn't dismiss it. He ran the numbers. The odds of this trajectory, this timing, this planetary proximity happening by chance? 1 in 20,000. The trajectory is not just unusual, it's aligned with Earth's own orbit. The timing places it near Mars, Venus, and Jupiter. The odds of that happening by chance? 1 in 20,000. And this isn't internet speculation, it's Harvard research. Peer-reviewed. Published. Contested, yes. Ignored? No. Yet the mainstream response? Silence. Shrugs. Dismissal. They insist it's coincidence that objects like this follow natural dynamics, not intent. But consider this: 3 interstellar visitors in just 8 years, after centuries of cosmic silence. Oumuamua. Borisov. Now Atlas. Each arriving with anomalies. Each too fast to capture, too late to fully study. So what changed? Have such objects always slipped past unseen, or are we entering a new stretch of the galaxy, one where things drift closer? And if so, what else is waiting out there? Because this doesn't feel like chance. It feels like pattern. The same corridor. The same angles. The same choreography. A comet is random. Debris is chaotic. But 3I Atlas feels designed. A flight path. A probe. A scan. And if it's scanning, then maybe, just maybe, something is listening. The object is here, moving fast, and soon, it will be gone. 3I Atlas races at nearly 60 kilometers per second, fast enough to break free of the sun's gravity forever. Its path is hyperbolic. Its trajectory open. It will never return. And worse, we're about to lose it. By late October, 3I Atlas reaches perihelion, its closest approach to the Sun. That's when it should be most revealing, shedding dust, ice, and gas, exposing its hidden composition under searing solar heat. But we won't see it. From Earth, it will be positioned directly behind the Sun, blinded, blocked, unreachable. A cosmic blackout. Ground-based telescopes? Useless. Hubble, circling Earth? Blinded by glare. Even Webb, a million miles out at L2, is bound by strict pointing limits to keep its optics from burning out. At the very moment the object becomes most alive, we'll be unable to watch. The timing couldn't be worse. We wait years, sometimes decades, for an interstellar visitor. And now, when one finally arrives with enough brightness, proximity, and mystery, we lose it. At the very moment it could reveal everything. Yet there's a sliver of hope. 2 spacecraft already in flight are drifting closer to 3I Atlas than anything else. NASA's Psyche mission, bound for a metal-rich asteroid. ESA's JWST, heading to Jupiter's icy moons. Both will pass within 0.3 to 0.4 astronomical units of the object during its peak activity, close enough to see it, maybe even study it. But here's the catch: neither mission was designed for this. Observing Atlas would require a course change, a fuel burn, a risky diversion. In deep space, every maneuver is a gamble, and every gamble could mean mission failure. Every kilogram of propellant counts. Every maneuver is survival. So, will they take the shot? That choice falls to mission teams, engineers, administrators, people who might not believe this object is worth the risk. But what if it is? What if this is our only chance to witness an interstellar visitor up close? To capture real-time footage, to analyze dust, light, and structure, not just from afar, but from within the object's own shadow? There's one more, radical option. Avi Loeb has proposed using Juno, currently orbiting Jupiter, for a last-minute slingshot toward 3I Atlas. On paper, it's possible. A perfectly timed boost could allow Juno to intercept the object in early 2026. It would be the first time humanity chases a visitor from another star. In reality, Juno's main engine is damaged. Fuel is limited. The mission is already stretched thin. Most call the idea fantasy, too risky, too late. But if it worked even once, it would be historic. Because after Atlas passes Jupiter, that's it. It fades. Its coma shrinks. The opportunity disappears forever. Its spectrum fades into the background hum of deep space. Then it's just another dot. Another ghost, lost in the void. And we're left staring at our hard drives, wondering what we missed. Because in space, there is no rewind. No second chances. Only motion and silence. Here we are, with the most advanced telescope humanity has ever built, aimed at a visitor from another star. And what do we get? Nothing. Not a failure. Not corrupted data. But silence, chosen, deliberate silence. They call it standard protocol. They say it's about scientific priority, about giving researchers time to publish. But this isn't a distant quasar. It isn't a star being born 10 billion light-years away. This is here, inside our own solar system. And the clock is running out. The data exists. The spectra exist. The high-resolution infrared maps exist. And yet, we cannot see them. They're real. And they're locked. Maybe they reveal nothing, just dust, ice, rock. Or maybe they don't. Maybe what James Webb captured in that narrow infrared signature, that faint spectral spike, is something we weren't meant to see, or weren't ready for. Maybe it's not about hiding data. Maybe it's about buying time. Time to explain. Time to prepare. Time to rewrite the story before the public hears it raw. Because what if the truth isn't just scientific? What if it's existential? What if something out there isn't just passing through, but watching? And what if it's been doing so far longer than we think? We once believed the universe was quiet, empty, predictable. That illusion is fading. All that remains is the unknown. So ask yourself, if this isn't a cover-up, why does it feel like one? If the sky is truly silent, why are we constantly told not to listen? If you're still listening, still watching, still questioning what's out there, subscribe to the cosmic unknown. Leave a trace. Because the silence won't last forever. And the next visitor might not knock. We may never get another chance to see 3I Atlas up close. Its spectra, its infrared maps, even its dust and ice locked away, waiting for someone to decide when the world is ready. But one thing is clear, the universe is not as silent or predictable as we once thought. And if you're still watching, still questioning, still wondering what's out there, you're not alone. Subscribe to explore the cosmic unknown. Leave a trace. Because the next visitor from another star might not knock, it might just arrive silently, and vanish before anyone notices.